Hello, my name is Stoyanovich, and today we will discuss defining AI. AI is great. The convergence of unprecedented data collection capabilities, enormous computational power, and broad acceptance of data collection and analysis as a way to move society forward are offering us tremendous opportunities to do good. We can accelerate scientific discovery in areas ranging from astrophysics to medicine. We can boost innovation in a myriad of ways, from self-driving cars to advertisement targeting and back. We can improve society by improving how governments function, by helping make resource distribution more equitable, and by bringing greater transparency and accountability to government operations. And perhaps most importantly, we can get AI to do all of our work so that we can just sit back and relax at the beach. But before we rejoice at the possibilities, let's unpack that term, artificial intelligence, or AI. What is AI anyway? Consider the task that many of us attempted with mixed results during the COVID-19 lockdown, baking sourdough bread. I will use this task as my running example to discuss algorithms, data, and decisions. Here's an algorithm. The first step is prep. Buy ingredients and measure them. The second step is mix. Combine yeast, flour, and water, cover, and wait for the dough to rise. The third step is knead. Shape, wait some more, and repeat. And finally, bake. The recipe is the algorithm. It lists the steps we take to transform the ingredients into a loaf of bread. The algorithm may be fully prescribed. It may list exactly what ingredients to get, exactly how much to take of each ingredient, in what order to combine them, how long to wait, and at what temperature to bake. We call such ingredients rule-based. If we know the rules well enough to write them down, and if we can always get exactly the same ingredients, then every time we will bake a great loaf of sourdough. But we may not always be so lucky. In fact, we may not know the rules of making a good sourdough to begin with. And we may also want to see some variety in the outcomes. An alternative to rule-based algorithms are algorithms that are adaptive, algorithms that learn. So how would an algorithm learn to bake? Well, we may keep the structure of this algorithm, of the recipe, the same, but try different combinations of ingredients, of mixing and kneading techniques, wait times, and baking temperature and time. And then we may ask a person, do you like how the sourdough came out? If so, we may keep these settings, or maybe we'll try slightly different settings, or a lot different, and we will see which results we like better. From this, we can figure out what ingredients and what combinations of parameters work well together. We discussed the algorithms. Now what about the data? It comes in multiple forms. One form is the combinations of ingredients we take as input. Another is the parameters of the recipe. And then there is data that describes the output, the loaf we baked. How much does it weigh? What is its nutritional value? Can we quantify the degree to which it's chewy on the inside and crusty on the outside? These are all objectively measurable factors. The final kind of data is human judgment. Did the loaf come out well enough or not? Is it tasty? Does it look good? This data is the subjective feedback that we get on the output. And more often than not, it's more important than some objective properties of the output. So far, we talked about algorithms and about different kinds of data. Now, what about decisions? In the process we described, a human is making a decision after every execution of the algorithm. Does the loaf look good enough to taste? Is it tasty? Are we giving it a thumbs up or a thumbs down? A decision that is more consequential is, now that we've tried a bunch of recipes, which will we consider a success? Will we decide to always or never use some specific ingredients or some specific parameters? Will we say that it's more important to have an appetizing looking loaf or one that consistently comes out as chewy on the inside and crusty on the outside? Next up, on the more consequential yet scale, is, do we think that we've tried out enough recipes to pass our experience on to a machine and trust that machine, that AI, to bake on our behalf? Will we trust the machine to bake something different, like baguettes? What about picking different ingredients? What about making judgments on our behalf? Deciding which baked goods came out well and which did not? How much autonomy do we give to a machine, to a learning algorithm, to an AI? So what is an AI? I would characterize an AI as a system in which algorithms use data and make decisions on our behalf, or help us humans make decisions. An example of AI is Roomba, a robot that helps us clean. Roomba is great at autonomously vacuuming the floor and is one of the first victories of classical rule-based AI. It's the stuff of textbooks. The decisions a Roomba makes are: what's a good strategy to clean an entire room that it may not have seen before? How should it map out the room? And what is its next move? Go left, go right, or turn around? Another example of a highly successful AI is IBM's Deep Blue, that beat Garry Kasparov, the legendary grandmaster at chess, in 1997. Several systems followed, including AlphaZero, that taught itself chess. This success at chess and at learning a complex game starting from basic rules is one of the holy grails of AI. The decisions in chess are more complex than those that Roomba makes, but they are similar in that they are strategic. What's a good overall strategy to take? What's a meaningful next move? And how to adjust the strategy in response to the decisions of the opponent. But now enter another potential application of AI, its use in hiring and employment. The decisions that we are asking an AI to make here are very different from those made by Roomba and by Deep Blue. We're asking it to predict who will do well on the job and who will not do well. The big question is, can an AI succeed at this task that amounts to predicting social outcomes? How do we know whether it has succeeded? How do we measure success? And do we want an AI to be making such predictions in the first place? Do we consider this to be ethical? If you'd like to learn more about algorithms, computation, data, and the impacts on society, I highly recommend the recent book, The Age of Algorithms, by Serge Abitboul and Gilles Dovec. To quote from the book, algorithms are probably the most sophisticated tools that people have had at their disposal since the beginnings of human history. They have transformed science, industry, and society. They upset the concepts of work, property, government, private life, even humanity. Going easily from one extreme to the other, we rejoice that they make life easier for us, but fear that they will enslave us. Creations of the human spirit, algorithms are what we made them, and they will be what we want them to be. It's up to us to choose the world we want to live in. Thank you.